manageable for the next machine, called a rotary mold. Inside that machine, a large roller flattens the dough pieces, forming them into a dense sheet about 1.5 centimeters thick. It then presses the sheet against another roller whose surface is a cookie mold. The factory uses the rotary mold machine for many different types of cookies. It simply installs the appropriate roller for the cookie in production. For marshmallow cookie bases, the mold cavities are round. The bases exit the rotary mold and make their way onto a moving baking sheet that transports them to an oven. The baking time and temperature are, once again, top secret. The baked cookie bases exit the oven and move onto a conveyor belt that transports them to a cooling area. Once they cool to room temperature, the bases go into a machine called the base feeder. It lines them up like marching soldiers to receive their marshmallow filling and chocolate coating. The process does require military precision. Factory technicians have to adjust this machine daily to ensure to-the-millimeter accuracy. A portion of filling has to land perfectly centered on each base, finishing off in a curled peak, this brand's trademark. The company won't divulge how much marshmallow filling goes into each cookie, nor will it reveal its marshmallow recipe. But marshmallow is usually made from either corn syrup or sugar and gelatin. And now for the final layer, the chocolate coating. Not only are the marshmallow and base covered in hot melted chocolate, the base floats in it, which coats the underside as well. Built-in air jets blow off the excess. The chocolate hardens inside a cooling tunnel. How long that takes and the tunnel temperature are, you guessed it, classified information. As the cookies exit the cooling tunnel, a quality control worker does spot checks to ensure the coating is thorough, hard enough, and thick enough. On the packaging line, the cookies go into plastic trays. To keep up to speed, the workers have to grab 4 cookies in each hand without breaking the coating. The trays pass through a machine that wraps them in plastic film. This keeps the cookies fresh and also prevents them from falling out of the tray. Meanwhile, another machine assembles the boxes, first folding and gluing one end shut. Once workers load the trays, the machine glues the open end closed as well. Then, with the go-ahead from quality control, the box's next stop is the cookie aisle of your local supermarket. Loudspeakers take an electrical signal and turn it into sound. The key to it all is a magnetic wire voice coil and a permanent magnet that attract and repel each other. As the coil moves back and forth, it rapidly vibrates a flexible cone. This vibrates the air in front of the speaker, creating sound waves. Loudspeakers contain at least 2 magnet and cone assemblies known as drivers. They're typically housed in a box called the speaker enclosure. To build the internal magnetic structure, the factory begins by cutting 2 plates of iron, each about 13 millimeters thick. They go one at a time onto a lathe. First, the machining tool smooths and evens out the surfaces, getting rid of the marks the saw made. Then it cuts out a small hole in the center of one plate and a larger hole in the center of the other. Next, they cut a smaller and thicker round piece of iron called the core. A reamer bores a large hole through it. They apply super high-strength epoxy glue to the core and to the back plate, the plate with the smaller hole. They glue and screw the pieces together because the bond has to be strong enough to withstand intense magnetic pull. They glue a foam filter in the hole to ensure the vibrating cone doesn't draw in dust and cause internal damage. Now they spread glue on the narrow end of what's called the metal basket, a die-cast aluminum frame that will hold the magnetic structure and cone. They screw the front plate, the plate with the bigger hole, onto the glued surface. Then they glue the underside of the front plate and one side of a ferrite, a ceramic ring made from iron powder. After adhering the ferrite to the front plate, they apply glue to the other side of the ferrite, then flip the basket over to attach the back plate. The core fits through the large hole in the front plate. They insert shims to center it while the glue dries. After screwing terminals to the basket, they put the entire structure they've just assembled into a magnetizing machine. With 600 volts of direct current, the machine creates positive and negative poles, transforming the magnetic structure into a permanent magnet, meaning it has a constant magnetic field around it. Now they wind the voice coil, the electromagnet that will interact with a permanent magnet. An electromagnet is an object that generates a magnetic field only when there's a current running through it. They wind enamel-insulated copper wire, gluing it to a rigid plastic sheet. The positive pole of this voice coil will be attracted to the negative pole of the permanent magnet. The negative poles will repel each other. The key is that the voice coil's poles are constantly reversing position because the electrical current running to the speaker is an alternating current, meaning it switches between a positive and negative charge several times per second. This makes the magnets attract and repel each other continuously, causing the voice coil to move back and forth rapidly. This vibrates the cone, which creates sound waves. After slipping the voice coil between the front plate and the core, they glue on the bottom suspension, flexible fabric rings that move with the voice coil and prevent it from rubbing